Our next major topic is called the chain rule. So here's the notation. We're going to take the derivative of f of g of x. So let's kind of write that out in English for ourselves. It says f of g of x. Okay, so basically the chain rule occurs when we have one function inside of another function. So as you can see, that g of x is inside f of x. So here's what the chain rule says. The derivative of f of g of x is equal to f prime of g of x times g prime of x. Okay? So here's how I like to think of it. I took the derivative of the outside, I left the inside, and then I multiplied it by the derivative of the inside. And I'm literally going to write that out in English, and I need you to do the same thing. You're going to derive, or take the derivative of the outside, leave the inside, and then take the derivative of the inside. And again, you're just going to say this over and over out loud to yourself as you're deriving these so they become easier and easier. This is a very difficult rule. We're going to break it up into 3 short videos. So here's example number 1. We're going to take the derivative of the quantity 3x minus 5 raised to the 6th power. So you might be thinking, okay, why is this chain rule and not power rule? So let me just quickly remind you that the power rule says you can only have x to a number. Okay, and basically what I have inside here is more than just plain old x. That's why this becomes chain rule. So now you have to identify who's inside and outside, and typically the inside is very obvious. It's inside something. So for instance, this 3x minus 5 is inside the parentheses, so that is my inside, and you can clearly see 6 is on the outside. Okay, so let's go through the rule. We would take the derivative of the outside. Now the outside is a power, so we're going to treat it like the power rule. We're going to bring the 6 down. We're going to leave the inside, like we just wrote. We're applying the power rule, so that becomes a 5. And now we multiply by the derivative of what your inside was. My inside is 3x minus 5, so its derivative is just 3. Okay, so let me just talk it out loud in case I went too fast again. Inside, in the parentheses, outside is out here. Derivative of the outside, so I'm starting with this. It happens to be a power, so I'm doing power rule. Bring down the 6, leave the inside, subtract 1, then times the derivative of the inside. The inside is 3x minus 5, the slope of 3x is 3, and the 5 is a constant. So now I just have to make sure I clean it up properly. I'm just going to multiply the coefficients together, so that's going to get me 18. And then I have 3x minus 5 to the 5th. Example number 2, the square root of 2x squared plus 4. Now, we talked about when we did power rule a lot of rewriting. So I am going to first rewrite this. This is really the quantity 2x squared plus 4 raised to the what power? Well, a square root is the same thing as a 1/2. Now is it very obvious again who your inside and outside is? I hope so. The inside is in the parentheses, and the outside is outside of them. So according to our chain rule, we're going to take the derivative of the outside. It happens to be a power, so I'm going to apply the power rule. So I'm going to bring down the 1/2, leave the inside, and according to the power rule, we subtract 1. So picture doing a minus 2 over 2, so that's going to get me a negative 1/2. Now I have to multiply by the derivative of the inside. So that inside was 2x squared plus 4, so the derivative of 2x squared is 4x. 4 is a constant, so we're done there. So the calculus part again is done. I'm just going to clean up my terms and multiply these coefficients together. So that's going to get me half of 4 is 2x. And then I have this junk inside here, 2x squared plus 4 to the negative 1/2. Now lastly, I'm just going to rewrite that with that negative exponent. I'm going to say it's 2x. That negative exponent will move all that to the bottom. And the square root again of 2x squared plus 4. Example 3. So we're going to derive the derivative 4 times the quantity 5x squared plus 3x plus 1 to the 10th. So just in case your gut wanted to take this 4 and multiply it through, I just want to remind you that's incorrect because all of this here is being raised to the 10th power. So you would have to multiply that out 10 times and then multiply by 4. So just to be clear, you cannot distribute that 4. So again, is the inside and outside obvious? The inside is in the parentheses, so there's my inside, and this outside is my power here. So I'm going to start with the derivative of the outside, so that's power rule. So I'm going to bring that down. So when I bring that down, I get 10 times 4. So hopefully you can do that in your head as 40. Leave the inside. Subtract 1 from my power, which gets me 9. And again, now times the derivative of the inside. So it's going to get me 10x plus 3. So 10x, or the derivative of 3x is 3, and of course that's a constant. Now again, I'm going to clean it up. I'm going to multiply any terms that are not raised to that power. So I'm going to say that's 40 times 10 would be 400x plus 120. So it's that quantity times 5x squared plus 3x plus 1 to the 9th. All right, example number 4, our final example. Again, the most important part here is the rewriting step. So I'm going to say all of this here is really to the 1/3 power, because that's a cubed root. So my first step is to rewrite this is 5 over 6x to the 4th plus 2 raised to the 1/3. And really you can do this in one step. I'm also going to bring it up to the top. Okay, so my rewrite is really 5 times 6x to the 4th plus 2 raised to the negative 1/3. Okay, so I've done zero calculus. I've just rewritten that with our algebra rules. Okay, now do you see that this is a chain rule problem? And that's the big deal. Do you see that it's chain? There is an inside and an outside. So inside, outside. So remember, take the derivative of the outside. So it's a power rule. When I bring that down, it's going to get me negative 5/3. Leave the inside. And now I have to subtract 1. So I'm really going to subtract 3/3, which of course is going to give me negative 4/3. And then times the derivative of the inside. So that's going to be 6 times 4 is 24x cubed. 2 is a constant, so it's gone. Okay, so now I just need to multiply. So the calculus part's done. I'm just going to clean up and multiply. This is being raised here to a power. So there's nothing I can do with that. I can multiply this term and this term together. So when I do that, 5/3 times 24, 3 goes into 24 8 times. So 5 times 8 is 40, so that's negative 40, x cubed. And then notice this has a negative exponent, so I'm going to start to do this more in one step. I'm going to move all of that to the denominator. So that's the quantity 6x to the 4th plus 2. This tells me it's the cubed root, and it's really going to be raised then to the 4th power. So I would say this is the final answer to that derivative. Well, hopefully you got a good feel on the chain rule, and we'll have a little practice for you.